This talk is about creative or hacker's way to use ELK stack by Milan Gabor. Let's start, okay? Please.
Okay, hi everybody. I hope you're enjoying your time here in Novi Sad. Are you enjoying? Or having hangover? Both? Okay, both. Then you enjoyed yesterday and you will do today. Okay, so a little bit, a little bit about presentation. So ELK, for that doesn't know it, so it's Elasticsearch, Logstash, and Kibana. You will get more familiar with ELK stack, but before that, who am I? I run the small company in Slovenia. Mogu da pričam, ali nećemo danas da pričamo. This is my second time in Novi Sad. Last year, we have been together with Almighty Daniel here presenting some other stuff. And since last year, I also fly drones. Because last year you had the drones, and I got hooked on the drones. So this is one of my pictures taken from the drone. And this is the last year. Last year we have been playing with mobile applications, and this year it's an ELK time. So what's going to be agenda? We're going to look into some hackers' problems, of course, hacker solutions, because we don't only want to talk about the problems. We're going to talk a little bit about ELK stack, and especially with combination regarding the visualization of mobile Wi-Fi. And we'll get some crazy ideas at the end, so you can try it. You can try it home. So, what is the problem at the moment with Wi-Fi and Wi-Fi visualization? Does somebody recognize this? Huh? Have somebody seen it here? Yeah, it's up there. If you don't know it, it's up there. You know, it's taped. Wi-Fi access points is actually taped pretty well, so it won't fall down. But do you know who's connected to that Wi-Fi hotspot? Huh? CTF? No, it's not the CTF. It was not CTF, but it was the Balkan Wi-Fi connector. But wouldn't it be interesting to see who is actually connected without writing single line of code? Would that be nice? Okay, you can do this. So you can do spectral analysis of 2.4 gigs or 5 gigs for visualization of Wi-Fi packets. But can you spot some packets here? Can you get some connection? Yes? Where do you see some packet? Huh? Here? Here? Huh? What kind of IP does it have? Huh? Yeah, come on. Yeah. So with this one, it's not so very good. Okay, we know this part much more better, right? So this is aircrack family, so aero dump. So you see that there are Wi-Fi connection. You see the MAC addresses. You see the probes that your phones are sending out, and some other stuff. Who never used that? Who doesn't know how this works? You don't know? Never used? No, it's kind of, if we now go to, let's say, here. So this is visualization of Wi-Fi traffic with aircrack, aerodump in this moment. So you see that my network card is jumping, so it's hopping the channels. And here you see actually the Wi-Fi access points and their MAC addresses, the power, manufacturer, and the rest of the stuff. So it's kind of terminal oriented. But wouldn't it be nice if you would have like this? Why visualization is so important these days? Because still our eyes and our brains can capture really fast if there is some really good visualization. So we're going to go today. I'm going to show you how you come from this part, so from hacker part to this without single line of code. No programming. Are there any programmers here? Who's doing programming? Okay, you like it, right? Yeah. Some yes, some no. Okay, but before we dig into, there are some other ways how to visualize or get some kind of information. PCAP to XML is one of that kind of tools, but the problem is that you get something like this. So with SQLite database, and the author of this tool is Vivek Ramachandran. I guess if you're into Wi-Fi, you know Vivek. You know he done some great hacks in the past. But the other challenge was, can we do it really without writing any lines of code and get a really good visualization without any programming? So that was our goal. That was our goal that we started when we started our research. Okay, but before start, what do we need? What do you think? What do you need if you want to see what's actually going on Wi-Fi? Any clues? Huh? Wireless card, yes. So you need a hardware and a software, right? So hardware, regarding the hardware, definitely your alpha wireless card or something else, some kind of good chipset. But for monitoring, you don't need some, let's say, really advanced chipset because you won't be doing any kind of injection. So a lot of USB cables. You're going to see that you need a lot of power if you're doing on a big Elasticsearch cluster behind. And you need a big screen. Why? If you want to visualize some stuff, if you try to do this on a 15-inch screen, you won't see that much. You're going to see that even on this projector, we will have some issues with that. And with the software, regarding the software side, it doesn't matter what you run, Linux, Mac, Windows, but you need to keep in mind that you might run into some kind of issues, especially if you want to run on Raspberry Pi. It is possible to run an ELK stack on the Raspberry Pi, but it won't run very fast. Okay, so we have now our hardware, so wireless card, one machine, and we have software, but we need two more things. We need environment, so whole elastic ELK stack, and we need data. So let's go with the environment. For building ELK stack, you need 3 components, or maybe 4 if you're doing, let's say, Logstash forwarder, so you have some sensors somewhere on the net. And ELK stack stays for Elasticsearch, Logstash, and Kibana. So this is kind of Kibana. So if you see something like this with Kibana 3, you will notice very fast that this is Kibana and this is kind of 4. So it's a major change, right? From black going to white and some other stuff. So, but it has some advantages already with the new version, but there are not so many features yet they are developing. So there are still some challenges left. So if we take a quick look at the ELK stack, so you have somewhere log shippers, so somebody who's actually pulling or pushing all the logs. Somewhere you have the Logstash server, which processes these logs, and then you have in storage where you put this into Elasticsearch, and then you have web interface with your Kibana, who's actually visualizing this whole Wi-Fi packets. I won't go into details step by steps. If you try to Google how to install ELK or Elasticsearch Logstash on Ubuntu, you will get really good tutorial, whatever you need to do it. There are several steps, no complication, it's not complicated. So if you have clean Ubuntu, you can have ELK stack running in, let's say, less than an hour or so, but it depends from your Linux or Windows skills. So just Logstash, it takes care for receiving and processing and forwarding of logs, and also kind of doing some transformations if you want. This is the mainly part of the Logstash. Logstash has also one component that is called Logstash Forwarder. It's actually just a small agent. It can collect logs or Wi-Fi logs from, let's say, small sensors installed all around the network. It's already pre-built for some platforms, but if you try to do it on Raspberry Pi or on some other exotic let's say, distribution, then you might then you might run into some kind of problems. But it can be solved if you use, for example, on Windows, you can use NX logs, or if you're running on, let's say, on Raspberry Pi, there is a Beaver, so it's a Python package, or you can just use syslog as a log slash forwarder for forwarding logs. The second part, the most important part, is actually Elasticsearch. It's hard to say. It's SQL, NoSQL, or something else. Actually, it's distributed search engine that you can be building up the big, large cluster, and it has really nice APIs. So if you're using Python, Java, or something else, you can do really good stuff with it. And it has REST API. It's open on port 9200. So if we want to try to play with, where's my, it's not here, but you can get the output just using the curl to the local host. And if you have just search string empty, and it gives you some kind of information already. So this part is Elasticsearch. And there is the Kibana who are actually doing this kind of transformation from output from Elasticsearch. It gets you something like this. And we're going to see how you're going to create in 4 short steps Wi-Fi visualization like this. And you're going to see that you can dig really good into these kind of pie charts. Does somebody has idea what's actually this or this and this and this? Any ideas? What can be on Wi-Fi? What kind of the data? I guess this is number of clients, right? Because there's lots. And the other stuff? Here, no. But we're going to build it. So you're going to see how it's easy to create this kind of the stuff and get even maybe to some of your phones. OK. When we set up an ELK, we definitely run into some kind of issues. First of all, if you're setting up this in some, let's say, hostile environment, there are some issue with, because there's no security. When you install Elasticsearch, it's there. You can just block it to block some NA IP addresses. But if you want to use some kind of advanced features like that's actually Elasticsearch has it. So for user authentication, you need to pay. It's not free anymore. Elasticsearch, it's free. And there are also some other components like Watcher, who's actually sending the alerts. And this is also not free. So it's actually under constant development. And there are some really big changes if you're moving from Kibana 3, so from version 3 to version 4. And sometimes you miss some kind of functionality. So you cannot do some stuff that we really wanted. And regarding the security, I checked on Shodan. Who knows what Shodan is? So Shodan is a kind of search engine, even better for the hackers. So I tried to search for Serbia, for Elasticsearch, and Shodan gives me 2 sites. So Kuitesa.net, CHPK, this is in Pristina, and this one is, I don't know, somewhere, mailprogrammatch.org. And their Elasticsearch is open to the internet. So if they have some interesting data, you just connect to it, issue a search, or maybe you can even configure your own Kibana, connect Kibana with that Elasticsearch, and you get all the data that's actually stored in that indexes. So that is regarding the security with Elasticsearch. Okay, so we got an environment. So we already built Elasticsearch. We can put inside the data. So we have our environment, but we still need data. So as seen before with this, where's my, so with this one, With this arrow dump, see, it gives you just a screen, so a terminal screen. You got an output from JSON. You have some tabular data, but it's not quite useful if you want to try to put it inside the ELK stack. So we tried the different things, because arrow dump, so AirCrank-ng doesn't speak JSON. We tried to run it. We tried to parse it. We tried to parse XML logs that can spit out from AirCrank, but nothing did work. So actually, the winner to do this, so to get the JSON outside of the arrow dump, was changing the source code. We are still thinking to contribute this to the main branch of the arrow dump, and we did a little bit facelifting of AirCrank. So the first thing that we noticed is, I don't know when exactly, but this number changed in last year and a half. What's actually here in original source code, it's number 10. And number 10, this is number of the probes that actually arrow dump keeps, maximum number of the probes that it keeps inside his list when it's running. Why did we have problem with this? Because most of our phones sending more than 10 probes. So I got a person at one conference, his phone was spitting out more than 100 probes. Who knows what the probes are? Okay, 3. Okay, so the probes are the specially crafted Wi-Fi packets that your phones are sending out with questioning, hey, I have been connected to that kind of wireless network. Is that wireless network here? So you're going to see in a graph that we can get a lot of this network probes. So with this, why would these probes would be interesting for the hackers? Because with getting those probes, I can locate where you have been. So going around, okay, I know you have been to McDonald's, you have been to Noisat, you have been to Balcon, you have been to DEF CON, you have been to other stuff. So first thing, we changed that. And the second thing that we wrote, actually the Daniel and I was just a little bit hacking the code, it's dumping right JSON. So with that change, we get all the data that we can get from the arrow dump, and we get something like this. So we got the station MAC address, first time that we have seen it, last time that we see it, what kind of power, BSSID, SSID, which probes we're sending it out, manufacturer, which kind of the phone. So we get this kind of output and we push it to the Elasticsearch. So this is Elasticsearch. We configured Elasticsearch our environment. We got the data. So now what? It's the same with a Google. When you open a Google, there's a search field, and if you don't know the right question to ask the Google, it's still the dumb machine. It's still a dumb search engine if you don't know the right question to ask. So we have been in this kind of situation somewhere in March. So we set it up Elasticsearch. We had the arrow dump spilling out all the data, pushing it to the ELK stack. And now what? So it's time for the demo. So we have been somewhere. In March. We have been somewhere here. So you see, we are getting. Is it visible in the last row or not? Or should I enlarge the font a little bit? Is it better? Okay, so we are getting this kind of information inside. So this is actually our original message here. You see, this is the original message from JSON, and then the Logstash parses it, and the Elasticsearch stores everything that all these fields for easier search. You see that we have the BSSID from the, maybe it's that wireless access point. We have the Wi-Fi name. We have the manufacturer. Actually, that's the phone. We have their MAC address. So in March, we have been like here. Is that useful? Huh? Yes? Yeah, yes and no. Okay, we have the data. Now, but we can create, with Kibana, we can create also the so-called dashboards. So you can have multiple visual elements on it. And you create with these visual elements all the dashboard. Okay, let's clear this. So this is the data for last hour. I have been sitting here at the presentation from my previous speaker. And in last hour, so we have seen 57 different ESE IDs. So from around here, around the neighbors, so 57 ESID. So 75 actual physical access points. Why this number is lower? Because you're going to see that BalkanCon has several physical Wi-Fi access points and only one BalkanCon SSID. And we have seen around 260 different phones, tablets, notebooks, whatever devices that were connecting or sending the packets over the air. So here we are also gathering the data. So open Wi-Fi's VPA, VPA2, who supports only VPA, and we can still have one web somewhere around us. So somewhere somebody could be cracking it at that moment. And here you have the names of the Wi-Fi access points with the strongest signals. So I guess somebody with, I don't know, City Hostel or something, CTF or Nova Historia was really near me. And then we can go drill down. You see, so the top clients, BalkanCon had around, maximum was around 120 people were here. So where is Jelena? It's now Milos. So we have around 120 people here from last 1 hour. Connected to the Balkan network, wireless network. But normally we lower a little bit this number. Why? Because some of the users, they're using 2 or 3 devices. So somebody is maybe with a phone or with a tablet or with a notebook, but let's say we have around 100 people here. So the next thing is what kind of the access point vendors we have. We have Pegatron, we have TP-Link, I guess TP-Link, Huawei, Cisco, Compex, and other router board. So MikroTik, it's around us. Here we have the number of the devices, so phones, tablets, and other things, and we see that LG Electronics is leading. So it's very good chance that most of the people are using LGs. Last week, I have been to the conference in Germany. Apple was winning here. Apple won a lot of time. Here, Apple is on number 3. So, huh? Mitterrhein Chaos Days, MRC ADM in Darmstadt, Germany. And it was really funny. If you try to run this on Frankfurt Airport, you know, where a lot of people are running around, you get the real good numbers. So you see that I have seen around 25 devices from an Apple, so phones and iPads and MacBooks here. Okay, then the, let's say, more interesting part can be also here. We have been discussing this kind of probes already here before. So you see, if I go over, this phone is I bet this phone has quite long history of, say, Wi-Fi networks. So you see that, I know that he has been going to Dante, so I guess he's getting a gas at OMV somewhere, using the telecom. He's been connected to Novi Sad, Biljana, Vila, Diana, Kristina. I guess that guy is coming from Serbia. So, see, his phone was sending out the 16 the probes. That's the maximum number of the probes. Let's try with another one. So, this one is Cigla. I know about Cigla, so it's not Jelena 021. Maybe this is phone from Jelena. Might be, Darkwood, Cigla, user, Suma. So Nasha Hedonia, I don't know. It might be. If you recognize that your phone is sending this out, please just raise a hand. So let me see if I can play Noah, no name. Okay, this one not. But let me, Divlja Kusa. I don't know if this means but I guess we're pretty close. But let's see, because I have been scanning this out now for 2 days. Let's see if we got some even more phones with more probes. So we're gonna go and say to Kibana display for the last 48 hours. So let's see if somebody was sending even more. So 13, 17. Guest. You see, this is Kiberpipa. I know the Kiberpipa is in Slovenia. So there is a really good guess that guy is coming from Slovenia. So, or have been at the conference besides this year when we did organize it. I know that Cox Tuscany rooms, this means Vegas. So I bet he has been to either besides Las Vegas or the DEF CON. Huh? Or both. Maybe on both. Okay, he's using Vodafone, Sprat Floor, The Link, Hotel 22, Sun Club. I'm not sure if this one is from Serbia or Croatia or somewhere, but I don't know. I know what kind of where he has been. But not only this, I can even take a look. I can take a look if I click on his Mac. Let's see. I know. Just take a look on his phone. So this is Intel. So I guess this is not a phone, but I guess it's a notebook. So he has been connected by a notebook. And let's see. He has not been playing our capture the flag because he was not connected to our capture the flag network. So this is everything with the point of clicks, no programming, no nothing, just filtering and displaying all this data. Okay, we have then, did I clean? Yes. We can also count the number of the clients on SSA IDs. So we see that the maximum number of connected clients to the Balkan network was 208. So that was the peak. So that I can assume that around 200 people were here or 300. So, but at the top moment yesterday, around noon, around 2 o'clock, that was the peak when there were the most clients. Okay, we can go even deeper. So there is this pie charts. So you can see that those are the phones, they haven't been connected anywhere. So since it's a hacker conference, it's not really safe to connect to the Wi-Fi, right? You might get some issues, but let's say we want to eliminate this. So we want to ignore that part. And now we get the Wi-Fi when my Kibana it's done. So you see, that's the number of the clients. So the biggest part was the BalkanCon 2K15. That was the most part. That was that network had the most of the users. And can somebody guess one ESS ID, and can you guess how many physical access points the conference had? 1, 2, 3, 4, 5, 6. So actually, this is a SSA ID, and these are the MAC addresses of the access points installed, something like this, or somewhere down below. And then you have Grad Novi Sad, so a lot of people have been connecting also. And here's our capture the flag. So we know we have been monitoring also the capture the flag because we have been preparing it. So yeah, the most number of the users at the moment for capture the flag 1 was 30, and capture the flag 2, so we had 2 wireless access points, was 21. So we had around 30 competitors, and this fits because we had like 33 registered players for the capture the flag. And if you go outside, so we have here ESS ID, so we have the MAC address. If you go outside, then you have MAC address of the phone, and you know that this phone that has been connected to our network was a Samsung. So you can go and deep dive really deep. So if we go for BalkanCon capture the flag 2, so we see that we had only 1 access point, and we had different kind of users. So that was with TP-Link. I saw yesterday one guy from Slovenia, he was competing, he had a TP-Link. So I know that was his computer that time. So there have been some Apple, LG, TP-Link, LG, Intel, some other stuff. So what do you think, how hard is to make this kind of the diagram if you have the data? Do you think it's hard? Do you have time to try it out? To make some kind of visualization so you see that it's really easy? Let's try with some pie charts. From a new search, we have, okay, our Wi-Fi. So what's our point of interest? We want to see the phones, so the devices. So we want to have unique account, so unique account of station MAC row. So station MAC row, this is, in this field, it's actually the MAC addresses of the all devices are stored. Okay, so we're gonna go now and split this whole bucket with SSA IDs. So the names of the wireless access points, and we say, let's say, go for 5 or 7 topmost. And we have here already, okay, these are phones that they haven't been connected to any network. So this one is BalkanCon, and this one is Novi Sad, capture the flag 1, capture the flag 2, Amsons, and Musée. So we can split, now we have ESS IDs. We can get then subaggregation and split this again regarding the BSE ID. So MAC addresses for the physical access points like this. So we have 1, 2, 3, 4, 5 for the BalkanCon. So if we go here, we have ESS ID BalkanCon, and this one has MAC address like here. So the next step is let's try to get MAC addresses of the phones. So we try to get this. This is the station MAC row. Okay, we have the wireless name, we have the MAC, and we have the MAC of the phone. So the next step, what we are still missing, let's see what kind of manufacturer made that phone that we have been on it. So this one is manufacturer raw. So let's say 5. Okay, apply. And to make a little bit more, we hide the legend so it doesn't show everything. So we have seen that somebody Balkan was at that time had 5 different connections, and this is Intel and I don't know, Niska, Honhai, Intel Introm, and some other tools. So we know that this Planet Technology device with this MAC address has been connected to access point with this for ESC ID Novi Sad. So was that hard? If you have once you have the data, it wasn't that hard at all. But there are plenty of different ways that you can do it, or how you can visualize this data. Of course, you have to have the data inside. So if you don't have data, then even such a great dashboard, it won't help you a lot. Down below, we also have, you can create kind of live streams. So actually what is coming in. So you see, this is the data 1 minute ago. So this is the BalkanCon, open network, Ubiquiti network, it's actually manufacturer, and Novia Historia, open network, it's a TP-Link. So this is coming from the wireless access points. And this one, you have the clients. So actually, what kind of the new clients have we seen? And this is done every 10, 15, 20 seconds. It depends from your configuration. But not only this, if you go from to discovering, you can also see this kind of stuff. So you see, since the network is open, since the network, BalkanCon and other are open, you can actually get, with AeroDump, you can actually get the IP addresses of the clients connected to the Wi-Fi networks. So you can do a little bit more digging, or you can do attacking, and we would have even more success if we would be doing some nasty stuff like de-authentication, all the clients, because that time we would get a lot more of the probes sending out and getting it in the dashboard. So that's the creative part, creative style that you can use the ELK stack for the playing. And you see, for the last few years, we have, well, my card have seen around 700 different phone devices. So the people come and go, getting around, staying somewhere outside of the conference. So it was definitely interesting digging into this data. But of course, if you use the ELK stack, there are definitely some problems. The first is Java. If you run Java, since Elasticsearch, Logstash, and everything runs Java, you have to have enough, what? Memory, exactly. But it's not always the problems. Just before the leaving for Novi Sad, I got a server from eBay with 64 gigs of RAM, 2 times quad-core Opteron for like 270 euros. So, it's a Dell with 12 base with a disk, no disk, just RAM, 2 quad Opterons, and I just installed the ELK stack and Elasticsearch, so I can share the details how it's going to be running. So after we come home, we're going to feed all your packets that you have, your phones has been sending out these last 2 days, and we're going to play a little bit with that. So definitely, if you want to play with it, Java, and it might be a problem. That's why it's also a problem if you want to run it on a Raspberry Pi, because Raspberry Pi Model B has one gig of RAM. But it's doable. There are some blog posts, so you can do it for quick analysis. The second problem is where to run this. Okay, if you're running at home, you don't get so many packets. If you run at the conference like this, it's more interesting. This is the Frankfurt airport from last weekend. You know, the airports are quite nice place to run this kind of stuff, because you can get millions of packets, and you can do analysis later on. So what we have seen with ELK, it's different filtering option. We are still discovering what Kibana and Elasticsearch can offer because it has really plenty of power. You can do even geolocation. So if you have IP addresses, it's really with 3 clicks, you can do geolocation of the points. No programming. And there are some crazy ideas like if you're running inside your company, you can use it for both, for the offensive and the defensive part. So for the defensive part, it's definitely if you want to see what's actually on there, what kind of the packets are flying around, and also for the defensive part, if somebody is connecting or somebody is misusing the Wi-Fi, your Wi-Fi networks, definitely you can use it in both ways. Let's say one possible way of using it, it's also you can set up a really some kind of intrusion detection system, simple, cheap intrusion detection. So if you know that you have only 10 management people that are using the Wi-Fi and suddenly you have 20 users and you get this on your dashboard, then there is something wrong. Or you can use it either for the stalking. So if you know where somebody is going on, if you know where somebody is eating at which restaurants, because his phone is sending out the probes, so you know which movement, where does he move. So you can do a little bit of tracking. And I guess it would be a really crazy idea, you know. We have been, now before the starting this day, we take a walk until the Donava River. You know, there is a really highway. If you set up on this highway and maybe on 2 other highways, let's say small sensors, you could actually track when people are leaving or coming and sending out these data. So it's a lot of possibilities. Okay, before we wrap up with the capture the flags winning ceremony, are there any questions regarding my talk? I know in Slovenia, people don't ask questions, but... Sorry?
There was an Elasticsearch meetup at the Meta Lab, so there are people interested in Vienna in this kind of area.
Well, you have my contact, you know. Just tweet me, and Vienna is only 2.5 hours from my place where I live, so it's not a problem.
It's also a cool tool to visualize all the stuff, and it's really easy to use, so you don't need like programming skill, and it's like awesome for people who don't know how to program. Yeah, so it's really powerful.
Yeah, it's really powerful, but you shouldn't get afraid when you have all the data. Then it's actually the work starts, because you have to have visualization, and you have to know what you're looking for. Otherwise, you know, it's just big bunch of data there.
But it's still a big help that you don't have to program all functions to get the data out and filter it, because you have everything out, just click and save.
Yeah. It was just clicking. I didn't do anything, and you can go drill down into deep. Yeah.
So much skills.
Yeah. Okay. Any other?
Okay. You said there is a possibility for IDS, right? Actually, I was thinking of the same idea, but what about a SIM? So can these data be fed to a SIM, and from a SIM it can take some precautions?
Sure, it can be parsed and put somewhere out inside. So with the Logstash, you have a lot of possibilities or getting from SIM and putting out on the SIM. So Logstash configuration, it's a great way. Or you can write some really short, small Python scripts and actually feeding the data into the SIM if something going on. Actually, the Elasticsearch company, it's now also developing the packet beat. So it's actually analyzing the packets on a low level. So it's kind of Wireshark, and it's feeding directly to the Elasticsearch. So you can just put interface in, and I want to monitor HTTP. But this is also not free. So you have to have the
Yeah, you have to pay for
support,
it.
yeah.
Okay.
But you can do whatever you want. So with this data, you can fed it, or you can ship it to another one to CM, and it has connectors and just sending out. And it speaks JSON. So,
Okay.
so everything is JSON.
Yeah,
So.
it's pretty easy. Thank you.
Any other questions? No? Okay, then the last part. One question, okay.
Is there documentation so we can replicate this?
What?
Is there some kind of documentation so we can replicate this?
Just drop me an email. Setting up the ELK stash, there is a lot of documentation. But sending this, I can give you a source code since it's not still in a repository of the aircraft, but I can help you, or Daniel will be gonna be more than gladly to help you with that too.
Okay, thank you.
But it's not step by step yet. But it's gonna be somewhere in a month or two. It's gonna be on our website, detailed description and whatever you can do with that.
Cool, thank you.
But before, I need to visit some other security conferences and then make a post on the webpage. So.
Thank you.
Okay, just the last stuff. Who has been doing CTF for the last 2 days? Okay, 1, 2, 3, 5, 6. Great. So you had a lot of fun? Was it fun? Yeah, we tried to we put a lot of effort in it. So it was like 2 weeks of hard work from Daniel. So Daniel, please give him big applause. He created. So if it was too hard, then blame him. If it was good, I will get this. So, and yes, finally we got a winner. As you can see, we got around 30 competitors. Before when I have been showing Kibana, we saw that's actually around 30 IP addresses has been connected, or more. So this number is real. We had some issues because somebody was hacking our competition system. You know, that's why we have users like this. You sure fix this bug, because we said we fix it and they prove we didn't fix it. Then this is our user. We know what you have solved, so we have been deleting manually their wrong submissions or abuses. But in the end, Hetty and Kluas almost, they have the same score, so they have been working as a team. They almost scored everything. But we were giving out some hints about how maybe to do it, not direct, but they did really good job. So we got something for them. So Hetty and Kluas, please come near and give them a big applause. So now we have a problem because they have been split, so not that you're gonna have to share somehow. This is first prize. It's actually infected, not by virus, but by Western Digital. So who was the? So you can do the.
It's the backup device for us both, so.
Okay, and the other one gets the 32 gigs. So, okay, give them a big applause because. They have been hacking since last 2 days, the whole night. So last night we even we left our machines running so they can do it after Rakia workshop. So you can imagine how it's to hack after Rakia, several shots of Rakia. But they managed a really good job, so I'm really glad, because if they wouldn't score so much, our let's say our time and our investment into CTF would gone for nothing, but I think you did a really good job, so hey.
We hacked till 12 o'clock in the evening, and then went to party till 5 o'clock in the morning. Then we went home with the taxi to Temerin, like 30 minutes away. Went to sleep for 4 hours,
Yeah. They're still missing the last flag, but okay, that's good for us. So we made it, and for that, guys that you haven't been competing, we tried to simulate real environment. So we had like honeypots, we had the Linux system, we had the Windows system, we had the games. You have to solve Sudoku, and you have to hack something. There's a small business server, there are a virtual machine, this is kind of real big fish company. So. Shells everywhere. So, okay, great guys, and hope you to see maybe next year. I don't know. Ask Yelena, maybe. I don't know. Daniel wasn't so much positive thinking, you know, about running the capture the flag. But definitely we had a lot of fun. So maybe next year. So. Okay, he drinks beer, large beer. So the beer is the magic word. To give a hint. Okay, and the third place is Josp. Josp is here? Or not? Too bad he didn't miss. So I want to just thank also to the BalkanCon crew because they let us run the CTF. We had some issues at the beginning, but I think you all enjoyed. So thank you very much and see you next year.